Oh, hey, physical science, we're back and we're about to talk about periodic trends. So get ready. That periodic table has a bunch of information and we're just going to scrape the surface of everything we can figure out from the periodic table. First trend we want to talk about is atomic radius, which is basically just the size of the atom. And we measure that from the center of the nucleus all the way out to the final outer electron. Atomic radius trend is as you go down the periodic table, the atomic size gets bigger and bigger. Now, why is that? Well, that's because every time you go down a level in the periodic table, you add an entire energy level. So as you add another energy level, you get a little bit bigger. So going down the periodic table, atomic radius gets bigger. Now, atomic size, as you move across the periodic table, surprisingly, you get a little bit smaller as you go across. Why is that? Because as you add a proton, which means you add protons as you go across the periodic table, those protons actually pull in, or for lack of a better term, suck in the electrons more and more. So as you go across, it actually pulls even harder and makes it smaller. So if you want to get bigger on the periodic table, you got to go to the left or you got to go down to get bigger. Here's a great graphic showing that. Now, it's not perfect. Obviously, going from left to right and getting smaller doesn't always work out. But for the most part, the trend is you get bigger as you go to the left and as you go down. And check out the size of cesium. Pretty big. Another trend is metallic character, meaning more and more metal. And that is the trend as you see in this arrow. The further down and to the left you go, the more metallic an object or an element is. And by more metallic, we mean that it reacts more like a metal, it has more metallic properties, etc. The opposite is true for nonmetallic character. As you go up and over, you get more and more nonmetallic. In fact, the most nonmetal element would be fluorine. We ignore those noble gases in that last column. If we talk about valence electrons, those are the outermost electrons in an atom. So this guy, this guy, this guy, and this guy. They are responsible for all the chemical and physical properties. So when an element bumps in near something else, all right, those loose or outermost electrons are the ones that do the interacting. Are they going to donate? Are they going to transfer? What's going to happen? So they're like the first line of defense for an atom, which makes sense why they're so actively involved in everything. All the inside electrons just kind of do their own thing. It's the outside ones that really matter, which is why valence electrons are so important. If you take a look at the trend, group number 1 has 1 valence electron, group number 2 has 2 valence electrons, group 13 has 3, 14 has 4, etc. So just drop the teen and you can know how many electrons there are in that outer shell. 8 is the magic number that we're looking for. Taking a closer look here, forgive me, this picture's off a little bit. This is group 13, this is group 14, 15, 16, 17, and 18. So the group number can help you figure out how many valence electrons. Atoms do want 8 electrons, and that's what makes them lose or gain electrons to get that full 8. And metals tend to lose electrons. So in groups 1, 2, and 13, they want to lose 1, 2, or 3 electrons, which actually, if we look into charge, losing electrons gives you an overall positive charge, because once you have less electrons, you have more protons, leaving behind a positive charge. For nonmetals, they tend to gain electrons. So in group 15, they have 5 valence electrons. They're going to want 3 more to make 8. So because of that, they gain 3 electrons, they get a negative 3 charge. 6 valence electrons, you're going to want 2 more to get 8 total. So because of that, you get an extra negative 2 because of extra 2 negative charges. Group 7, you only need 1 more to get 8, so you get a negative 1 charge because you gained 1 electron. If we take a look at metal and nonmetal reactivity, and forgive me, the picture's cutting off the words a little bit, but the larger the metal is, the more reactive it is. And the reason for that is all these energy levels of electrons. The bigger the atom, the easier it is for those electrons to move away because they're not sucked into the middle by the positive nucleus. So the bigger the metal, the more reactive it is. That's why francium is crazy reactive. You would never find it on this planet just in the pure form because it's already reacted with something. Now if you look at the nonmetal reactivity, it's the opposite. The smaller the nonmetal, the more reactive it is. And that's because the smaller it is, the more it can pull on outside electrons. Remember, nonmetals gain and metals lose electrons. So the bigger you are, the easier it is to lose. The smaller you are, the easier it is to gain because you can pull on electrons more. So that's why nonmetals increase in reactivity the higher up we go to the right corner. Overall, we did talk about the trends. As you go up and over in the periodic table, these are the things that happen. Your radii decrease. Your nonmetal reactivity increases. Your metal reactivity decreases. Your nonmetal character increases. Your metal character decreases. And your valence number, when you go over, increases, right? It goes 1, 2, 3, 4, 5, 6, 7, 8. All right, this is just brushing into the basics of periodic trend. But as we watched in our video, Dmitri Mendeleev he was at least one of the founding fathers that got credit for the periodic table. He put an order by atomic number, but man, there's way more to it than just an order of the protons. And you can start to see that now. Thanks for listening.